Alright, welcome to the Windows installation video. We're actually going to install a Windows virtual machine. There are two different types of virtual machines to cover real quick. PV, or Para-Virtualized Virtual Machines, and HVM, and I forget what the HVM actually stands for, but I'm guessing something like hypervisor or similar. But the HVM machine has emulated equipment instead of para-virtualized. Para-virtualized actually maps to the real equipment, so obviously para-virtualized is superior in performance in most cases. However, since x86 virtualization, HVM has actually taken off because the only way that you can get Windows to work in a virtual machine environment is with HVM. Now, there's also the advent of para-virtualized drivers on HVM, which is what we're going to be installing in our system later. So keep that in mind as we go through this. What I highly recommend is that if you're new to Zen, that you take a look at the Zen man pages. There are configuration files here that give you details on all the different flags and information that you can set in a virtual machine configuration file. In addition, there's details on the disks, formatting, network, all that sort of stuff. In particular, I've cheated a little, and I actually already have a configuration file. So this right here is my configuration. I have the name of Windows. It's an HVM. It has 4 virtual CPUs, or vCores essentially. It has 6 gigs of RAM, and it's going to be using Xen Windows, which is a logical volume I have not yet created, so I'll be going through that as well. And right now, because we're doing the installation still, it has a CD-ROM with an ISO. So you can use the physical CD-ROM, obviously, but I find that an ISO is just going to work way better. And we previously created a network bridge, a virtual bridge, and that's what we're using to connect to the internet. So this thing's going to use that for internet access. Now, in addition to that, this is important. All of the MAC addresses for devices in Xen Virtual Machine should start with a 00:16:3E. It's the Xen reserved address naming, so just keep that in mind. I know that some people have run into problems. I've had it working without this prefix, but I guess it's just not recommended. And if you run into problems, that might be why. Now, you can ignore these lines for now. We're not going to be getting into PCI Pass-through until later in this video, but this is how it is done. Or at least a segment of it for how you'd configure it in a virtual machine, and I'll explain it more later. Now, we've set it to boot from the DVD drive first, or CD drive, and then the hard drive, which means that D comes first. D refers to a CD-ROM. C refers to the hard drive. Don't ask me how that works. I don't know where the naming came from, so I think it's a little reversed personally. We're going to be using SDL for the beginning, but I will be demonstrating how this can be done with a VNC connection, because both are applicable, and both can be done from local machine, and VNC can be done remotely. So, important to note, local time. This is set to 1 because without this and MTP on the host system, the time can drift on the Windows virtual machine, and I've had it sometimes even a month out of date, and it wouldn't fix itself. And the problem isn't just the time, it's the fact that when the time was offset, I had icons disappearing from the taskbar, I had SSL certificates that claim they were expired, and various other problems. I highly recommend that you make sure your time is synchronized. Without it, you will experience problems, and when you do, they will not be pretty, and they will not be easily fixed. This line right here is also commented out. This is for the PV on HVM drivers we'll be installing. After we've installed them, we enable this line, and it will start to use those for various components. So, let's see, what else am I not covering yet? Oh, here's a couple of limitations for you. Let's actually create our virtual partition first. So we're going to do LV create, which is part of the LVM tools, so Logical Volume Manager, LV create-L for the size, and we're going to use a 40 gigabyte partition for now. The nice thing about partitioning for logical volumes is we can very easily resize it, but resizing the partition is not going to resize the hard drive itself, and I'll be explaining that in a minute as well. We're going to give it the name of Windows, and we're going to give it to the Xen grouping. So this will create Xen-Windows. So, and next we go to some limitations on hard drives and how that works. A virtual machine made in Xen, when we send this partition, this logical volume, to Xen, it will treat it as a physical hard drive, which means it will create a new partition table and subpartitions inside of it, which means that you can no longer just mount that partition. You have to have an offset value in order to do that, and I'll be demonstrating that possibly in a later video, but it is in my guide under the managerial tasks, or it will be anyways. But the general idea is this. The virtual machine environment allows you to sub-partition. So I made a 40 gigabyte partition. I could create 3 or 4 additional partitions inside of that and use them separately inside of Windows. So that is an option. So some of the actual limitations, and the reason I use Samba, are because you can only mount up to 4 different HDX style drives, where X would obviously be A, B, C, D, etc. And that is just a limitation because it mounts them as parallel ATA drives, and it can only do up to 4. Now, in addition to that, there's also a limitation on SDX drives, and SDX is not serial ATA, but it's SCSI. So SDX, or SDA, SDB, SDC, etc., are SCSI drives, so you can't boot from a SCSI drive, which means you have to have an HDX or similar drive, and then you can have SCSI drives after that if you wanted for more sharing and whatnot. The problem is that if you have it mounted in multiple virtual machines, and it will let you, neither of the virtual machines will inform the other that changes have been made. So if you try to write from both at the same time, they could easily overwrite data from each other, which would wreck your drive. It'll do all kinds of damage in terms of either crashing one, if not both of your systems, or resulting in data loss from both ends. So, ill-advised. That's why I recommend Samba. Now, we're using logical volumes. You can technically create a file instead. I don't really find that to be as useful, and it's harder to move around, resize, and whatever else you need to do. So, let's see, what's next? I have a list, and this is the first time I've actually gotten to this point, so I can actually demonstrate it all. Now, again, I have an ISO of my Windows 7 installation, so it's at this location on my drive right now. It's actually in one of my shared folders. Well, let's go ahead and boot our system. We're actually going to do XL create, and we have to create a full pointer to this location and this file in particular. Most of the files for configuration for virtual machines should be put into the Xen directory. However, it's totally up to you if you want to do that. You can put the files technically anywhere on the system, and you can still point to them, but you need to give XL the path to that file. So I could run XL create windows.cfg from inside that directory, but because I'm not there, I have to run with the full path. All it's doing is it's using this information to create our virtual machine when we hit enter. Now, it's important to note that you have to do this every time you want to boot up the virtual machine. So whether you do it remotely or from terminal here is up to you, but this is one of the key reasons why I wanted Zen over ESXi, because that platform did not have a way of doing this that I was aware of. So we're going to launch it, and what we should get in just a minute is either this will error out saying that we don't have the correct configuration data, or if it's successful, it'll create an SDL-X window, which we can use then to interact with our virtual machine. And there it is. This here is an SDL window. Now the nice thing about SDL is it is direct visual, so it is not a network connected visual, which means we interact with it directly. So it's like most modern virtualization platforms in that sense. VNC is a remote connection, which means when we interact with that, we're doing it over the network. So we're going to install Windows, and this will be hopefully a nice, easy, straightforward process. So like I said, it's going to create a system reserve partition, and then this one here, I'm going to format it now so that it saves it some time during the install, because if you wait, it can sometimes lengthen the install. And then we're going to do the install here. This should only take a couple of minutes. So. By a couple, I mean probably about 7. And you know what? While this is going through, I can actually walk us through PCI Pass-through and how all that works. So let's clear this out real quick. First, get familiar with LSPCI. LSPCI is a way to list out the information on all the PCI devices on your system. So you'll notice I have, for example, the controller for my PCI bridge right here. This is the main PCI bridge for my entire system, and it's 00:01.0. That notation right there is called BDF notation. What it is it's bus device function. So you have the bus, the device, and then the function. And the reason that's kind of interesting is because you can have one device that may have multiple functions. For example, my Radeon card by AMD has an audio on board as well as video. So I have a function 0 for video and 1 for audio. But this device information is important because this is what you need in order to identify the card on Linux or the device on Linux. So in our case, I'm going to be passing 01:00.0 and 01:00.1 to pass my graphics card and onboard audio for that device to the virtual machine. Now, in addition to this one, I'm going to be passing my USB controller here, as well as both of these USB 3.0 controllers. So I'm going to have, I believe, 6 USB 2.0 ports and 4 USB 3.0 ports available to me in my virtual machine. Now, I don't have to pass them all to one virtual machine, and technically, if one machine is shut down, I can pass the same equipment to a different virtual machine. So you can actually flip-flop it and use it any way you like. However, in order for us to pass a device, we need to make sure that our DOM0 is not using it. Now, LSPCI will list it regardless of whether or not it's being used. It's because the system identifies that, hey, this is plugged in. But that's not to say it's being used. What is the problem, though, is that we need to make sure that the system ignores it, and that's what PCI back does. PCI back can be loaded as a module, and you can perform a late binding, but I'm not too familiar with that approach. I haven't really tested it out. I'm in the process of creating, hopefully, a script which I'll release in the future that will automate that process. I know that there are scripts that exist, but I don't think they exist and allow you to do as much as I would like to see. So, in any event, we're going to actually open up our favorite file, the grub configuration file in our boot directory. So we have boot, grub, and then grub.cfg. And of course it's not opening because it didn't say VI. Okay, so grub.cfg is the file that is going to contain the line that we need to modify in order to pass our devices. So we have this module line here where it loads our VM Linux. You may remember that from manually booting if you had been there with me previously for that. What we're going to do is we're going to append to here, and we're going to do zen-pci-back.hide. And then we're going to set it equal to, and that's a comma, so that'll be a problem. Hold on. Alright, zen-pci-back.hide equals 00:1d.0. And then I also have to do the same for all of my items here. Now, just to let you know, when a device has multiple functions, if you pass one part of it, it will not work. You have to pass both. And it may automatically attempt to do that for you. So if I had just attempted to pass 01:00.0, it may see that there's an additional function of that same device. Most devices do not have split functionality. You can't just take one half of it. That's not to say that I couldn't pass only one to the virtual machine either. But again, it's usually you have to pass both. So if you have something that has multiple functions, it can create all kinds of havoc, and I'll show you why in just a moment. Now, because this is the grub configuration file, we have to force right quit, so I'm going to do that real quick. And we have to reboot for this to take effect. Now, once this goes into effect, there is not an easy way to undo it. It would be essentially removing lines from a few different files. So just keep in mind that undoing that process will be difficult. So next, what I was going to show you is that, let's see. Let's see how our install is doing real quick. Oh, that's a problem. It looks like it, oh, there it is. It automatically restarted because the install just finished. That's actually pretty fantastic. I don't think I've had that happen to me before. Anyways, as I was actually saying, if we actually go to VI at Xen Windows, we can now uncomment these lines, and we'll reboot the system later, and then reboot this virtual machine. Because Windows is going to install this in just a moment, we can get rid of all that, and hopefully, now it will not reload this configuration file until we've literally shut down this virtual machine and restarted it. So we can do this without interfering with this process here. It won't do anything to the system. Again, that's just a configuration file that is read when you create the virtual machine. So all we're doing is we're essentially saying, here's the configuration for the machine we want to start. So LSPCI, here's what I was going to show you. This is important. If you have a device that has multiple functions and you pass one of them, you may incidentally pass all of them. So for example, I have this ISA bridge controller chipset and it's on 1F. And then there's additional functions, 2 and 3, that control the SATA controller and the SM bus. What if I wanted to pass just the SATA controller for my hard drives, right? Well, if I did that, I would actually incidentally pass the SM bus and the ISA bridge at the same time because of the fact that they are connected to the same device. This means that if you had something like, for example, in one of my previous motherboards, I had my Ethernet, the onboard LAN was connected, as well as several other types of inputs, and then it was a USB controller, right? And all of those were on this one device area, this one bridge for PCI, and that when I passed just the USB, it also passed the Ethernet and a few other devices, and I was unable to get the system working after that. So you want to be careful of that. Just be aware of it. So again, it's restarting for us, so hopefully we'll have it back in a minute. There we go. Now you notice it's trying to boot from the DVD, but the install is finished, so it's actually going to boot Windows now. So I won't bore you with the nitty-gritty details of this process here, but I will say that once I've installed this, install all the Windows updates possible. That should be your next step. Once you've installed all the Windows updates you can, then you're going to want to reboot the entire physical machine so that the grub menu updates. So I'm going to cut it here because I don't want to need this video to be that long. You've already seen that this is accessible, and we're about to go through the whole process. The next time that I start this video up again, I'm going to be recording VNC access and installing the ATI graphics card, and I will have to go through some webcam in order to demonstrate that because I can't record screen capture and a monitor at the same time. So, okay, and we're back. I have restarted the system, and now we should have past devices, and we can check this by running XL PCI assignable list, and this should show us all the devices that we added to Grub. So I now have both of my USB 3.0 controllers, one of my USB 2.0 controllers, and my graphics card. All passed. Now, also to demonstrate exactly what I was talking about before, each of the configuration files are just configuration files. They're just instructions. So you can actually have multiple sets of configuration files that load the same virtual machine but with different information. So for example, for this test purpose, I'm going to show you that we can use VNC instead to launch a virtual machine without having a direct connection with SDL. When we do SDL, as soon as the window is closed, the X window, it will shut down the virtual machine, and this obviously is a problem if you wanted something running in the background. So there are other benefits and reasons why you might use VNC, or neither in some cases. To use VNC, we're going to set that value to 1. I just deleted the SDL value, so it's not a big deal. We add VNC listen. What this is going to do is it's going to tell what subnets to listen on. Essentially 0.0.0.0 is saying listen to all incoming traffic. This is obviously a security problem. If you were on a public network, you might want to use something like 127.0.0.1 because that'll be only listen to the local host for access. You could also use a subnet. So for example, if I wanted only things behind my current router, I might use 10.0.1.0, which would specify anything on that subnet. Now the :10 here is actually a display port, not a port number. VNC console starts at 5900, which means display 10 on VNC would be port 5910. Depending on the software package you're using, most of them will accept a display number, but sometimes you may have to specify a port number. Also for access, I usually set a VNC password. This is so I can access from my laptop. My laptop's VNC access requires that I enter a password, otherwise it simply won't accept that I'm able to actually connect to it. So I can show you as well. But what we're going to do is we're going to create our virtual machine like before, but this time we're going to use VNC, and this will load the same virtual machine. Now at this stage I have already installed every single Windows update available to the system, and a few different software packages, as well as configured the system in general. So this way, right here, will create the virtual machine for us, and then we just have to try accessing with VNC. Now, I installed GVNC Viewer previously, so what we're going to do is GVNC Viewer, localhost 10. And here it is. This is Windows through GVNC Viewer. The reason I like GVNC Viewer over Xtight or the built-in VNC Viewer is the fact that it allows you to resize the window without crashing. Both Xtight and the default VNC Viewer that comes with Debian, both of them crash or just shut the window, close it completely as soon as the window is resized. So, for example, that right there would have crashed. And it might just have anyways. Just a moment. Okay, so I'm not sure exactly why we were disconnected, but in any event, this is a network connection, so it's a little laggy. It's much more so than when we were connecting through the other type. Now, this is important right down here. PCI Pass-through itself is really, really simple. You're just mapping direct access to the devices, but there is a couple of problems with this. The graphics cards, most of them, do not have function level reset. When you shut down this virtual machine, you're not changing the power of any of those devices, which means those devices are not being reset automatically, most of them. FLR, or function level reset, allows you to send a command that resets a device instead of a power change. Normally when you reboot a computer, it automatically happens. Obviously, not the case in a virtual machine environment. That means that every time we reboot the system after passing the graphics card to it, it'll cause a problem because that graphics card may no longer be able to function properly because it's already been previously initialized. This is a serious concern because of the fact that it breaks general functionality. And it causes degraded performance. The biggest problem, though, is that if you reboot the system before installing the driver, or if you've rebooted the system and are updating the driver or removing the driver, the process may fail. Now, sometimes it'll say that it succeeded, but it still fails, and that means that you pretty much botched your system. You have to either reinstall or go through a whole lot of trouble to get it back to normal. So my recommendation for you out of precaution is to always reboot the entire system anytime, the entire physical system, anytime you're going to do a driver installation. If you can't reboot the system, then I recommend that you go to here and you select to eject the device from here, and this will automatically reload the device as soon as it finishes the ejection. So it'll go black screen for 3 seconds, and then you'll get video again. Now, this is version 12.8 of the ATI drivers, or AMD ATI drivers. So we're going to install this, reboot, and when we reboot the system, it will no longer have video through VNC or SDL so long as the graphics card is passed, at which point I'm going to switch over to show you access through webcam so I can show you that the video does actually work. Now, just a note, I grabbed the GPLPV drivers, which are right here off of specific website. I don't actually recall the exact name offhand. It's something to do with Meadows, but if you type in Zen GPLPV, we can find out details right here. There we go, meadowcourt.org/downloads, and I just grabbed it off of this one right here. So it says Vista x64, but it does work for Windows 7. So, and I'll be installing that after I finished with the graphics card. I also have both of the drivers from my motherboard's INF files and for the USB 3.0. The INF files for the motherboard contain the stuff for your USB 2.0, so if you want to grab that, you can do it. The default Windows drivers will probably work just fine though, so sometimes they don't, but most of the time they do. Obviously I have a bunch of other software that I'm installing and setting up on the machine, not really important or relative to this guide. So at this point the installation has completed, and if we go to view the results here, it'll give us information stating that everything was a success. So at this point, if we restart the system, the card will no longer be fresh. So this is going to ask us to, and I'm actually going to instead just say to shut down. I'm doing this out of precaution. So I'm going to shut down the system and reboot the entire physical machine before starting it back up. And that should freshen the card for when it finishes the installation process. Again, this is entirely optional whether or not you choose to do it that way. I recommend it simply because it'll prevent problems. So XList tells me that there's only one virtual machine running, and that's domain 0, so that means we're all set there. So I'm going to cut this recording, and essentially we've finished the Windows installation and the driver installation for the graphics card. It's really not all that hard. You just download the driver and install it. But if you don't have a fresh graphics card, if you've already passed it and rebooted the system several times without rebooting the physical machine or resetting the card itself, then again, the installation may fail. You may face a blue screen of death, and if it happens even just once, and you attempt to remove it, what happens when you do that is you reboot the system. So again, you're rebooting the system, the card is no longer fresh, and then you're attempting to communicate with it to remove the drivers, which causes problems. Again, failing to actually properly uninstall the drivers, and that, again, leads to more severe problems. So, in any event, thanks for joining me for this recording, and any feedback or requests regarding the information beyond what I've shown here, feel free to do so. I will be appending to this later on the demonstration of performance, probably once I get some applications installed that can do that for us.